Hello and welcome. It's your friendly neighborhood math teacher, Mr. Allred. I'd like to welcome you to lesson 5 called Balancing Moves. In this lesson, you'll get an introduction to balanced hangers, which is just another way of representing equations. Earlier in the unit, we talked about tape diagrams in our lessons called smudge receipts and equations, and we use those tape diagrams to find missing values. This model is similar to tape diagrams, but it's all about balancing. So in this lesson, you'll develop strategies for figuring out an unknown weight by creating balanced hangers with fewer objects. It's the first of a 2-lesson sequence. So in the next lesson, you'll actually connect determining these weights to solving equations. In this lesson, you're just going to get a chance to work with the hangers and figure out how they work by following these two learning goals right here. Determine an unknown value in a hanger diagram, explain a strategy, describe and use moves that will keep a hanger balance, like adding or removing equal items from each side, things like that. In this video, I'm going to go over slides 1 through 6 with you in this video and help you get started on those slides. And then in math class, we'll work on slides 7, 8, and 9, which are the lesson synthesis and cool down slides, as well as a cool little gallery activity. So this lesson's pretty short in comparison to other ones, and we're going to get started right now by talking about slide 1. Slide 1 is the warm-up slide. It's going to ask you to balance the hanger by clicking on the shapes to add them to each side. So what you can do here is if you want to add a triangle to the left side, you can click the triangle. And then if you want to add a few triangles to the right side, maybe a square or two, then you can add that there on the right side. Okay. My first challenge to you would be to try to add things just to the right side to make it balance. Make sure to make the sides different. And then if you want, you can add a few things to the left side, reset it, and try to balance it again on the right side. But just take a few minutes to explore on this warm-up and try first to balance the right side right now by using a different combination of triangles and squares. It does give markings, of course, on the triangles and squares as to how much they weigh, how many units they weigh. So those things are marked there on the triangle and the square. So go play for maybe 3 minutes with the hangers, try to balance them using different combinations, and then come back to Edpuzzle. Awesome job. Hopefully you're able to see at least one combination here. I noticed that with the hangers I had 3 squares, and the squares are each worth 2. I knew 3 times 2 was 6. And then I had 2 triangles that the triangles are both worth 3. 3 plus 3 is 6. So I knew I had 6 plus 6 is a total weight there. That's 12. One way I knew I could combine those to each other, or balance them rather, I knew I could use 4 triangles to balance it because 4 times 3 is 12, right? Another way to balance it would be to use 6 squares, right? 6 squares to balance it because 6 times 2 is 12. So hopefully you are seeing that if you want to balance something, then you can look at what you already have, see how much each item is worth, and that might help you figure out how many of each item to use on the other side if you want to use a different combination. On slide 2, you're actually going to start solving for the weight of items. So on slide 2, you're going to figure out the weight of the square so that this hanger stays balanced. You're going to assume that it already is balanced, and you're going to try to figure out how much the square weighs. So go use your big, amazing brain that you have and try to figure out what the weight of one square is there on slide number 2. Come back to Edpuzzle when you're done. Awesome job, guys. Real quick, I'm just going to talk about this one. So I've got 1, 2, 3, 4, 5, 6, 7, 8 things that weigh 2 each. 8 times 2 is, of course, 16. So I know the total weight of this side is 16. Then I counted the number of things I already had on the other side. 1, 2, 3, 4 things that weigh 2 each. 4 times 2 is 8. So I knew that if the whole thing was supposed to weigh 16, and I already had 8 units taken up, I knew I had 8 units left to cover between these 2 squares. The thing is, there's 2 squares, so I split the 8 that I had left over in half to figure out what one of them would be worth. And I determined that the weight of one square would need to be 4 there for that one. So hopefully that helped to solidify any answers or choices that you made there on slide 2. A great thing to do now would be to email me if you still had a question about slide 2 before we had class again. If not, ask me in class tomorrow. Here's slide 3. On slide 3, your job is to press play to see how Adnan determined the weight of a square, and then you're going to describe his strategy. So see what he did, and then describe his strategy in your own words. Again, you can press play if you want to see his strategy again, but I want you to just try to describe his strategy in your own words, please, on slide 3, and then come back to Edpuzzle. Awesome job, guys. On slide 4, it says if hanger A is balanced, which of the following hangers will also be balanced? Your job is to select all that apply. So there you got, it's telling you, right, that hanger A is balanced. So you can assume that that is true. Your job is to figure out which of the other ones would also be balanced if the weights of the things are the same. This is a little bit of a brain teaser, but I think you can do it. Go to slide 4 and try to figure out which ones would also be balanced. The best advice I can give you is that I know that they have at least 2 things that are the same, right? So these squares would match up. This side has 2 squares, and this side has 2 squares, but it has 3 more squares. That means that you know something about these guys, and I want you to see if you can figure out how that one's balanced and see if you can pick another one that would also be balanced on slide 4. Go work on it, come back to Edpuzzle. Truth be told, right, since I know these 2 squares are the same, that means that I know that these 2 purple circles have to equal the same amount as these 3 squares do. Okay, so I know that 2 purple circles equals 3 squares. I do know that for sure. So one thing that can help me if I'm looking at this one is I know that F would have to be balanced as well, because that one has 2 purple circles that match up with 3 squares, and it has 1 pair of squares left over. Okay, I also would know a few other things. Oh gosh. The other ones that are also balanced are C, D, and G, and we'll talk more about that in class tomorrow. But at least if you see how F is balanced, then you can feel free to move on to the next slide. We'll talk about the other ones in class tomorrow when we review it. Moving on to slide 5. In slide 5, your job is to solve it again. It actually gives you numbers this time for the squares and the circles, and your job is to describe how you would figure out the weight of a circle, and then to actually find the weight of the circle and check your answer. Make sure you check your answer and click try it to see if you're right before you move on to slide 6. Go work on slide 5 and come back to Edpuzzle. Awesome job, guys. Here's the last slide we're going to review today. This is Zoe's strategy. It says this is how Zoe made a hanger with fewer objects. It says, will the new hanger be balanced? So your job is to tell me if her new hanger will be balanced, if she took away those things right there. Say yes, no, or I'm not sure, and then explain how you know. Go work on that, and then come back to Edpuzzle. I'll dismiss you from the video. Awesome job, guys. Thank you so much, for working on lesson 5 with me called Balancing Moves. We'll talk about it more in class tomorrow, of course, but we appreciate all the hard work and effort you put into it today. Make it a great day or not. The choice is yours. Go team.